So I'm going to assume that you guys have finished these pieces. Now, this right here is a good chunk of what you would expect from a free response question. Typically, though, for a free response question on the AP exam, there'd probably be more words because, they like to make it more complicated. It's wonderful. No, not so much wonderful. But these are the general ideas. You're not going to be given here, I want you to do this, 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 and this. This is a little bit more clear than what sometimes you'll see for your instructions. Okay? So let's take a look at what I would expect to see for your work here. First thing, you want to make sure that you identify what your parameter is. In this case, P, because it's a proportion, and we say it's the proportion of heads. Do not tell me the number of heads. Do you understand what I'm talking about there? The number is a count, and that's a different kind of test. So this is the proportion of heads. And you want to list out your important bits and pieces here. So what I did is really the biggest number that I found was important was 140 over 250. That's my p hat, which also tells me what is my sample size. What's n? 250. So I like seeing it as a fraction. A lot of people are like, oh, I'm going to put that as a decimal. Woohoo! Decimals are well and good, but if you have to round it, you have to show where it came from. Okay? Because they are more concerned with you understanding where it comes from than what the physical value of that is. Okay? And then we have the confidence level. I just put it there so that I would remember that Z star, so that I could get all of those things. And you'll see me kind of do those in different orders whenever. The big thing is it has to be found on your paper. And I think with the last Frappy that we did, you'll see that they don't always look exactly at the exact same things. Somebody said it yesterday that I was like, oh my God, that's the perfect description. It's trying to hit a moving target. You know we're aiming for, but they keep blinking in and out the different targets. So we're just going to buckshot and try to hit the whole entire thing so that the ones that they are lighting up, the ones that they are looking at, get hit also. Okay? Then for our conditions, you need to talk about this one, that your coin flips are independent. They're looking specifically for that. Independent coin flips. And if you say coin flips are independent, you don't need to check the 10%. Why do you think you might not need to check the 10% condition in this case? Because it's infinite. There's no limit to how many coin flips you can do. And so checking the 10% condition of infinity, really cool thing if you ever take number theory, is infinity. Mind explosion. What? 10% of infinity is infinity. Yes. So this guy right here wouldn't be counted as a necessity in this question. The coin flips being independent would. Okay? Then we have our NP and NQ. And please notice what numbers what did I use for P? One more time. P hat. I should have used P hat. Why am I used P for some reason. I should have used P hat. So there is a mistake on this. This number here should have been 140 and then 110. Because a confidence interval, which is what we're doing here, a confidence interval is focused on what? Your sample. Whereas a hypothesis test is focused on the population, the hypothesis. Okay? So when I do this, when I'm looking through my pieces here, conditions met one prop Z interval, they kind of go back and forth as to when they expect you to show the model. I really wish I could give you a more clear thing here, but for our model, we are following the normal model, centered at what? What should be my mean for the normal model in this problem? 140 over 250, my p hat. And then my standard deviation for this model is that 140 over 250 times 110 over 250, all over 250, square root of that whole thing. Okay? When I show you your calculator steps, you're going to understand why I tend to just write this. But since we're doing all the steps, you need to write that down. You need to see that it's centered at p hat, which is that, plus or minus z star, which is that, square root of, I would need to list n and q hat in order to be good for just using this formula. And then there's your answer. Did we get similar answers to that? We okay? And I can tell you, when they do a confidence interval, one of the pieces is going to be, did you get the interval correct? Okay? But even if you got the interval, like if you forgot the steps, you could make an interval up. It's one of those things we're going to be looking at. You want to maximize your score. You can make stuff up. You're like, dude, I'm going to lose that point anyway. Make stuff up. Grab back the points for the conclusion. Okay, say, 14 out of 25. That's about, 60%. Let's go up a couple, down a couple from that. I'm making it up. That's my interval. So you lose those points. You can still get this. As long as you say, based on our sample, we are 95% confident that the true proportion of heads when flipping a euro coin, because this is specific here, is between those 2%. And so if you had your answer wrong here, but you used it correctly here, you would get that conclusion point. That's nice. Okay. Yes, ma'am. It does not. If you're using a percent, you must have a percent symbol. Beyond that, doesn't matter. Okay, because 48.9 is not a proportion. That's why. Anybody else with the meat of the matter? Okay, then there were the other questions for part B. 50% is what we're looking at for fair. 50% does fall within the interval. It doesn't matter that it's close to an end. What matters is that it is in the interval, so therefore, I can't claim that it's unfair. Remember, whenever we make our decisions here, we're going towards that alternate hypothesis. When we're in a jury trial, we don't ever say, we found the defendant innocent. You assume innocence until proven guilty, but if you haven't proven guilty, then you just say not guilty. And that's the way it's true for all of our hypothesis tests. Okay, the next question was talking about what your alpha would have been. For this question, would this have been a one-sided or a two-sided test? Two-sided? Why? Right, because we're looking at not fair. It's not going to be fair if it goes either direction. More heads, less heads, doesn't matter. It's not fair. So that's a two-tailed test. What's the relationship between alpha and the confidence level? 1 minus. Is there a divide by 2 in there? No, because it's in the name, right? Two-sided. So it's 1 minus the confidence level. So alpha here is 0.05 or 5%. How do you feel? Yes. It's okay.
So if it's one-sided, you can say what you divided by 2.
Right, and the way I was explaining it last class is I said we have a two-sided interval. Alpha is 1 minus the confidence level as a decimal. For a one-sided, we don't have the 2 up here anymore, so alpha is 1/2 of that, or you can say 2 times the alpha is 1 minus the confidence level. So you're going to have the 2 in there someplace. It's either in the number of sides or it's in the formula. Okay? And that's the only way I can remember it. I'm like, I don't know. I don't memorize things real well. It's not my strong point. Okay. So really, this section, this idea of this more about tests and intervals is, it's going to be the same for everything that we do from here on out. These ideas of errors, powers, confidence intervals versus hypothesis tests, these are not really going to change. So we spent a couple of days on it here because we're not going to let it go. We're going to hold on to it for dear life. All right? It never dies. And the great thing is right now, today, we are still focusing on these 3 statements. I swear, putting these things on magnets, best thing I ever did. Smartest decision. If I can actually get them to go up on the board. Here we go. All right. So last class, we were really focusing on the errors themselves. A type 1 error, that's my pregnant man. That means I rejected the null, but I shouldn't have. The type 2 error, that was my woman who's about to pop, but she's not pregnant. So that's when I failed to reject, but I shouldn't have. This is what we did last class. This is what we did last class. This is exactly what we did last class. Okay. The part where people have problems, and this is true about teachers of statistics. They have problems with this idea of a power of a test. Power of a test is a hard number to come up with. And when they're doing that, they're talking about beta. Beta is an actual number that you can calculate, but you can only calculate it if you know what is actually going on, what is actually true. And if you know what's actually true, you're not going to do a test. So that's where the kind of the difficulties there lie. But what you have to understand is alpha pairs up with a type 1 error. This table here is hugely important. And also understand that I have no control over whether the null hypothesis is true or false. I am not going to move that line, ever. That line is wherever the truth is. Okay? We can adjust alpha, which will pull this line up or down. Okay? Alpha is your probability that you reject a true hypothesis. That's bad. Alpha is the one thing that we really control the most of, because that's really subjective. It's like, well, what is your problem? What is your cost-benefit analysis? What's worse? What type of an error do you want to make less? Making the correct decision if the null hypothesis is true is 1 minus alpha. Don't worry too much about beta, that symbol. Worry about the phrase, the power of the test. And if the power of the test is this box right here, what can I do to make that box get bigger? To have more power? Just looking at this, what can I do? More alpha. I want more power. I can increase alpha. If I increase alpha, what am I doing to the confidence level? I'm lowering it. If this gets bigger, 1 minus alpha, the confidence level gets smaller. These are relationships that you need to understand. Now, the power of the test is this correct decision, because this is what we're doing. Our whole purpose of doing a test of any kind, or even a confidence interval, is so that if there has been a change, we can identify it. Think about a jury trial. The reason we go to trial is to get those people who are guilty. Right? We don't go to trial to prove somebody's innocent. That's not the goal. The goal of a trial is to get the folks who are guilty. That is the power of a test. The null hypothesis is false. I should go with the alternative, and I do. That's the power. Okay, so that's what we just talked about. Don't worry too much about, like I said, the actual value of beta. If you move on to upper level statistics courses, they'll talk about the hypothetical. Okay, let's say that the actual beta, the actual proportion was this. Calculate your power. I've done that in one of all of the graduate courses that I've taken. And it wasn't even on the test. Okay? So don't get too wrapped up in that. Just understand that the power of the test is the ability to correctly reject a false null. And likewise, we can increase the power directly here by increasing the alpha, but doing good things increases power, so increasing our sample size will also increase the power of a test. Okay? All right. Hey, look, that's what I just said. I've given the spiel a couple of times, right? Yes, ma'am. Because when you increase alpha, the confidence level is 1 minus alpha. So if I make alpha bigger, I'm subtracting by a bigger number, so I'm making the confidence level smaller. You think about it, they all balance out to be the whole entire normal curve. Alpha are the pieces on the end. The confidence level is the piece in the middle. If I make the ends bigger, I make the middle smaller. Okay? Is that good? Anybody else? Okay. All right. I love this. I was so proud of myself when I came up with this. Are they even doing American Ninja Warrior anymore? It's coming to DC. Are you serious? Are you serious? Oh, when are they coming? When are they coming? When are they coming? That would be so awesome. So, and this is that really amazing, like she's about like this tall, but she's a powerhouse. But American Ninja Warrior is a great example of the power of a test. The null hypothesis for Ninja Warrior is that you're just a normal person. We reject the normal person when you pass this test. When you have your alpha level, that you get past it. So if my test is not powerful enough, if you look at the first season of American Ninja Warrior, it had a really small wall. Right? It had a very small wall. And as the seasons went on, they were letting too many people pass this test. So they increased their alpha. Okay? Get what I'm talking about there? You want to reject more false nulls, you increase the power of your test. Okay? This is a meme I made myself. I was so proud of myself. Thank you. Wow, I almost fell flat on my face doing that. That probably wasn't good. See, it looks a lot prettier when it's dark in here, right? Yes, but then you can't see anything when you're writing. So, you prefer that? But think about it that way. More power, more ability to reject the null, more alpha. Okay? So the way that you can, again, if I go back to that previous idea of the grid, type 1 errors and type 2 errors are on opposite ends of that movable line, that alpha line. So if I make one bigger, I make the other smaller. There's very little I can do to make them both smaller at the same time. There's very little I can do, but there is something I can do. To make both of those smaller, you can increase your sample size. Increasing your sample size is always good. And there's a concept that talks about an effect size. Don't worry about that. I haven't seen that. They mention it briefly in our course description guide. I think if they actually put that on the test, I think half of the AP Stats teachers would quit. Because it's not an easy concept to understand. But don't worry. There are technically two normal curves going on. There's the normal curve that's centered around your sample, and there's the normal curve that's centered around what's actually true. The effect size talks about the relationship between those two, which is also a little bit about the power. So if you're reading through the chapter, because everybody in here reads the chapter, right? And guys, if you find like class difficult, I love our textbook. It is fantastic. For a math textbook, it's very readable. So if you're sitting there going, read the book. It's okay. It's okay. They might explain it slightly differently. For now, there's only one way that you can reduce the type of both errors at the exact same time, and that is to increase your sample size. Okay? The only way you can cut back on both a type 1 and a type 2 is to increase your sample size. Otherwise, decreasing type 1 increases type 2. It's a trade-off. Okay, that's the only thing that you can do. And by the way, increasing the sample size is also going, oh my God, word explosion! Increasing the sample size is also going to increase your power. So, yeah, words. Read them, thar words. This is what a frappy would look like. So read through this and ask yourselves for this problem, what would your P be? How would you write at least the symbols for your null and alternative hypothesis? Okay, you think you know null is equal to, but what would your alternative be? And talk to each other about that. It's kind of weird. It's backwards to the way I actually think in this problem. If I was a bank, I would do it the other way around. Talk. Turn to your elbow neighbors. No. Ooh, Eden, I like the way you described that right there. That was a very good point. Eden just made a really good point. To come up with her alternative, she thought about, well, which one would the bank care about? Would they care, would they be, are they going to be worried if your points are too high? Are they going to be worried if your points are too low? Too low. If your points are too high, they're going to be like, yay! They're not going to run screaming for the hills. They're going to be more concerned if your points are too low. So the null hypothesis is going to be that equals to, and technically we're happy about the greater than side also. But the alternative hypothesis here is going to be less than. And think about it this way. They reject your loan application if your score is too low. Does that make sense? And this is the type of thing that makes this class difficult. Words pull the meaning out of it. Because now what we're going to do is we're going to take this and we're going to answer questions. So you might want to write down here that P, what was P? What are we looking for? What's my thing that I'm measuring here? What's my null hypothesis and what's my alternative? Because we're going to go through and we're going to say, okay, now what is the type 1 error, the type 2 error, the power of the test, all in context. But this isn't going to fit on the screen with those questions. So write down, what is it that we're testing? What's my null? What's my alternative? Because when you have those physically written down in front of you, it makes doing these interpretations so much easier. And this is why banking has stats. Mm-hmm. Yes.
So I did this, the point.
Oh, so you're looking at the previous problem? Mm-hmm.
Yeah, the point one. And I lowered the confidence level.
And your interval should have gotten bigger.
It went, this 0.49 got to 0.5.
Right. Oh, I'm sorry. Okay, so did you increase your confidence level or decrease it?
Decreased. I went from 95
Yeah.
to 90.
Yeah, because what you're doing here, if you want to think about it, all the possibilities, this is 95%. This would be 90%, 80%, 70, 60, 50, and working inwards. And the power of the test is the ability to correctly reject. So that means that the rejection region on the outsides get bigger. Okay, so when my region pulls in, this is getting smaller, which means the outside, the rejection regions are getting bigger. Okay? Because if we were looking at that problem, when I use a confidence level of 0.95, 50% is not in there, or 50% is in there. When I decrease my confidence, I get more accurate, and I'm more likely to catch if that's an unfair coin, and immediately the 50 falls out of that interval. Okay? All right, so for this problem, you should be, like if you want to think about P as your point total, or P as the percentage of points that you have that are possible, the null hypothesis would be that you equal what they want you to have. And so the null hypothesis, if we're thinking in terms of context, the null hypothesis is going to be that you what? You make good on your loan or you default on your loan. Good. They're not worried if you make good, if there's no change. The null hypothesis here is going to be that you make good on your loan. The alternative would be that you would, do you know what that term is? Default. The alternative is that you're going to default. That's what they're concerned about. They're concerned about defaulting. They're not concerned about the people who pay it off ahead of time. Be the person that pays it off ahead of time. Just saying. All right. So, if a person does default on the loan, in order for someone to have defaulted, what has to be true in the first place? If you're going to default on a loan, you would have to have had the loan in the first place. Does that make sense? In order to default, you have to be given a loan. And if they give you a loan, what are they believing is true? That your score is good, that you're going to... Right, they failed to reject. They said, okay, in order for you to default, you had to be given the loan in the first place. To be given the loan in the first place, they had to believe you were going to pay it back. They're not going to give you a loan if they don't think you're going to pay it back. That's not the goal here. But you defaulted. So what type of an error is that? Type 1 or type 2? Type 2. They thought you were going to pay it back. They went with the alternative. They shouldn't have. Type 2. Person was not a good credit risk, and the bank didn't catch that. Okay, type 2 error. The null hypothesis was false, but we didn't see that. Okay, so what happens when the bank misses an opportunity to make the loan? Still a mistake. The first one was a mistake. This one's also a mistake. The first one was type 2. What's this one? Okay. This is a type 1 error. I like this, my little wink, wink, nudge, nudge. Hey, guess what? The first one was a type 2, so what's this one? Okay. When we're looking at this, the bank misses an opportunity. Again, the null hypothesis is that you're going to pay it back. If they missed that opportunity, that means that they rejected, but they shouldn't have. That is the type 1. So you rejected, but you shouldn't have. Okay? Now, if the bank chooses to lower that cutoff score, just kind of stop there. Lowering the cutoff score. Are more people getting loans or are less people getting loans? More people are getting loans. Okay? Is that going to be the same thing as choosing a bigger or a higher alpha? More people get loans. So does that mean more people are rejected or fewer people are rejected? Fewer people are rejected. What has you rejecting less times? A larger alpha or a smaller alpha? Rejecting less. Everyone's a smaller alpha. You reject less. Literally, alpha is how often you reject. This is the tricky part. Power is the thing that always throws folks off. Power and errors. Yeah. Mm-hmm. Uh-huh. And that's the bad part about that example. So basically, with the alpha, increasing the alpha, we're more likely, in that case, the rejection was saying you are not normal. Okay, so that's where that one was just a little bit different. Okay, so in this case, we're saying we're lowering the credit. And think about the way that I'm making this thought process. Lowering the credit score, more people get loans. If more people get loans, I am rejecting fewer. And it's that rejecting that gives the alpha. If I'm rejecting more, my alpha is getting bigger. If I'm rejecting less, alpha is getting smaller. Okay? So if they are rejecting fewer people, alpha is all about the rejects. Get it? Alpha is all about the rejects. Who am I rejecting? So if I make fewer rejections, that means it's easier to get the loan, which unfortunately it was happening in the whole country a few years ago when all of a sudden it went crash, crumble, and houses values fell and people defaulted on loans and foreclosures and everything went screwy because they had cut back the requirements so much. So you got to be careful. So if I am going to change that cutoff value, my point score from 250 to 200, if I am rejecting less, am I going to be having more type 1 errors or fewer type 1 errors? Fewer type 1 errors? Fewer type 1 errors. And the reason why I didn't even ask about type 2 errors, if one goes up, the other goes down. What's the only thing that will affect both of them at the same time? Sample size. Very good. Very good. Okay. This is that nut that is hard to crack in statistics. This is the context. Okay? I truly believe you guys can regurgitate all of this information at me. I'm not worried about regurgitation. This is not a memorization class. I'm worried about can you apply it. So if I talk about power of a test, can you just read what it says for the power of a test? Okay. The ability of a test to correctly reject the false null. What was the null? And if we put that in context, we believe the person will pay off the loan. Power of the test is the ability to correctly reject a false. So translate that into this context. Power of the test is the ability to correctly reject a false null. Our null hypothesis is that the person will repay the loan. So correctly reject. What would we say if the null hypothesis was false? It's not that they've got bad credit, because people with bad credit, they're bad credit risk. But what decision do we make if the null is false? What do we hope we make? What was the null hypothesis again? That they repay the loan. And if that is false, what's the flip side of somebody repaying a loan? They don't. They default on the loan. Do you understand where I'm going at with this? Power of a test is reject a null when it's false. So that means the power of this test is to reject an applicant if they're going to default. Do you understand? This is what you have to work on. And I can see some people drifting in and out of consciousness. If you need to stand up in the back of the class, that's fine. This is hard. You want to actually focus on this. So the probability, again, the probability of their test to correctly reject, that means that they denied a loan when the person would have defaulted, when the person would not have repaid. I'm getting nothing but blank stares, and I have no idea if you're... Yeah. Okay, this is going to be one of those things when you do your homework for this unit, it's not going to be a lot of numbers. It's going to be a lot of thinking. Okay, sometimes that hurts more. Use your brains. It's like doing a whole bunch of squats when you haven't done them in years. Ow. Use those brains. What could the bank do to increase their power? They could increase their sample size, which means they have more people in their pool of applicants. What else could they do? Increase alpha. How does alpha relate to this case? The what? Oh, beautiful, babe. Cutoff score. The cutoff score. So if I increase alpha, what am I going to do to the cutoff score? I'm going to increase it. Okay, it's this whole little cause and effect change. So to increase power, they raise the cutoff score. That means increase alpha, reject more. Reject more. More people don't meet that minimum requirement. What's the disadvantage of doing that? Why would a bank make it harder to get a loan? People are going to stop going to the bank. That's the purpose of a bank. A bank is not there for some altruistic need of the community. That's not what they do. Bankers are not known to be the most altruistic people in the world. That's okay. We need them. The purpose of a bank is to make money. They make money off of loans. That is what the interest rate is. If they raise their cutoff score, what's going to happen? They have less money because less people are paying back loans with interest. That's what banks like. And so when we were going through that whole crisis as a country, the banks were like, I'm going to rake in hand over fist interest from all of these people to make as much money as I possibly can. And then if that person defaults, it doesn't necessarily hurt the bank, it hurts the person first. Okay? So the bank loses out. More people are going to be denied credit. They remove that opportunity for them to incur their interest. All right. Words! Blech. Whole problem. Work it out. There's no math here. It's just thinking. You can do this. Write it down. All of your errors, type 1, type 2, are easier if you are physically looking at your null and alternative. And in this case, you don't need to say P is equal to, P is greater than, P is different than. Just think about it in terms of the context. What do we hope happens with the null? What are we worried about with the alternative? Or what would we like to happen with the alternative? Okay, so read through this, talk this out, and for goodness sakes, write it down. Not the whole question, the answers. All right. So, for this problem, what do you think? Is this a one-tailed or two-tailed test? It is a one-tailed test. Why is it a one-tailed test? Because we're interested in knowing if the dropout rate decreases. We're not looking for just a change. Our goal is actually for a decrease in the dropout rate. So the null and alternative hypothesis, what would be the, let me see if this actually, okay. What would be the null hypothesis, just in words? The dropout rate remains the same, remains at 13%. What would be the alternative? The dropout rate is less than 13%. It decreases. Okay? I don't remember what the next question was. So how do we make a type 1 error? If we're looking at this, type 1 error is when we choose to do what? We reject when we shouldn't have. So that means we went with which of these two statements? We reject, that means we go to the alternative, but we shouldn't have. Do you understand? This is why it's good to have these written down. Type 1, we reject, but we shouldn't have. We reject in favor of the alternative, but the null is still true. So the type 1 error is if they go with the software, thinking it's going to help, but in fact it doesn't. Happens all the time in education. See, these really great, some of these presentations are like, oh my gosh, you've cured cancer. If we use these textbooks, everything is going to be, no, they're just really good presenters. Okay, so then the next one was a type 2 error. So a type 2 error in general is when you do what? You failed to reject, but what should you have done? Reject. So we believed what was true. We believed the dropout rate was the same. We believed there had been no change. But in actuality, it actually decreased. So did he buy the program or not? He didn't buy the program. So he doesn't buy the software, but it could have helped. Okay? I think E was the power of the test. Was E the power? So what's the power of the test here? Power of the test is that we do what? Correctly reject. So if I reject, I'm going with the alternative, and I should have had. I buy it. So we buy the probability that he does what? The probability that he buys the software when it is in fact helping. Okay? This is harder because this is about context. Numbers are clean. Numbers are beautiful. You can't misinterpret 5. It's the words that go into describing it that makes this the most difficult thing. All right, let's try another one. This, I believe, is in your notes. I think so. Did you brush? Yep. I really hope you did. Please, if you didn't, just lie and tell us you did. Pretty please. I don't care. I want you to brush your teeth. I want to live in that. Procter & Gamble is the... I love you. She just said, isn't Procter the guy from the Crucible? Procter & Gamble, it's kind of like Johnson & Johnson. They're the companies behind it. Thank you so much for that. All right, so you're not just doing problem number 1. You are going all the way through to problem number 8, ladies and gentlemen. Yup, it's like a whole page. Does everybody understand what I'm talking about? You have this in your notes. This only shows 1 through 3 because it's all that shows on the board. You are doing 1 through 8. I'm going to give you guys some time to work through 1 through 8. All right, so, yeah, it's okay. No.
For number 6, when we do it, do we need to explain like power decreasing power and
But what they want you to do there is make sure you put it in context. So yes. So what does that mean in real life? All right, so looking at problem number 1, just kind of working our way through, make sure we're at least progressing in the right direction. The null and alternative hypothesis. What would the null hypothesis be? Yeah, the proportion of people that buy the Crest toothpaste is the 19.5% or 0.195. The alternative, what's my alternative? P is greater than. Okay, so the null hypothesis is that there's been no change in the number of people who purchase Procter & Gamble, their toothpaste. The alternative is that it has in fact increased. So looking at this, a type 1 error, in general, a type 1 error is that you rejected, but you shouldn't have. So going to this, you went with this, but that was true. Do you understand what I'm talking about? If I pull completely the context out of it, that's a type 1. And then we just move it back into the words. So the type 1 error is believing the percent of people who use Crest is greater than 19.5 when in fact it hasn't changed. Do you see how I did that there? Okay, so it is concluding that there has been an increase when there actually has not been. The type 2 error is you failed to reject. we stuck with this when that was true. Okay? So the type 2 error is believing there has been no change in the proportion of people who use CREST when in fact it actually has gone out, has gone up. And then if I missed the part here where it says the impact such an error would have. So if we believe that it went up when it actually didn't, I'm wasting money on a program that didn't really do anything. In place of the other ones, I'm missing out on a chance to sell more toothpaste when it actually would have helped. Okay, that context needs to be kind of woven back into that. Are we okay with those? Okay. I think did you guys get 5 and 6 okay? Yes. Let's pull off. That's like the big central thing. And I understand that. That's frustrating. Okay, so what conclusion should they make based off of their 98% confidence interval? Anybody want? Yeah.
I said that they should fail to reject the null because the null is within the confidence interval.
Good decision, no context.
Oh, they should reject the new marketing campaign.
There you go. So what you see here, her interpretation was correct. My alternative was less than. Is my entire interval less than my hypothesized value? What was my hypothesized value? 19.5 or 0.195? Is this entire thing less than that? No. So the decision would have been that you failed to reject the null. They would say they would not go with the marketing campaign because they don't have evidence that increases sales. Is that okay? Again, don't get hung up on just the math of it. Put your contacts back in. That is the hardest part. For this test, we did 98% confidence interval. We know what my alternative hypothesis was. Is that a one-sided or a two-sided test? One more time? One-sided. So what would alpha have been for this? Beautiful. Alpha would have been 0.01 or 1%. One-sided test, divide by 2. If I used an alpha level of 5% instead, what would be an advantage to that? What would that do for me? It would increase the power of the test context. You're right, but how do I put that into this context? The power of the test is to actually, the likelihood that we actually catch that this is an effective campaign when it really does help. And what you need to do for this is you have to put it in context. If you leave out context, let's say it's a 5-point problem, you get 1 point. Do you understand the importance of that? I'm not asking you to find power. I'm asking what is an advantage and a disadvantage. An advantage, we're increasing the likelihood that we know when the advertisement is helpful. The disadvantage is you might accidentally make the decision that it's helpful when it's actually not. Okay, but you see how all of that is about context. Okay? Gee, there's a reason why I like the word context. Making slashes on a piece of paper. It'd be interesting how many slashes we would have for this block alone if you took a tally mark. How many times I said the word context, context, context. There's 3 more tally marks. All right, we are running out of time, so I want to make sure that we finish this up. If we extended the trial period, basically what are you doing? Increasing sample size. So what will that do to the power? That will increase the power. Increasing the sample size increases the power. If they see a rise to 22% of shoppers and they say, hey, it has increased it, why might they still not choose to invest in the campaign? Oh, freaking glorious. Even though there's been an increase, the cost of that campaign might not be met by the increase in sales. That's a net negative. You don't want that. Very good. So next class, please, please, please bring your notes with you. Remember, your homework for this chapter is due tomorrow night. Even though your quiz isn't until later, I didn't want you doing. I know you guys, you're procrastinators. I'm not enabling you on that. But bring with you next class that packet. Okay, that's really all you need. But I'm going to show you some amazeball things with a calculator. Just in time for the quiz. Okay? All right. You peeps are awesome.